Convection. So another method of heat transfer is we call convection, which is the transfer of heat by mass motion of a fluid from one region of space to another. Unlike with conduction, there must be a contact between two bodies. While here in convection, it is the flow of fluid that transfers the heat. So from one space or from one region to another region. As an illustration, let's see this. Let's say we have a pot that contains a liquid, which is a fluid, basically, and being exposed or applied hot temperature or heat at the bottom. So the lower portion of the fluid or the liquid being exposed directly in the hot temperature gets warmer. So the tendency in atomic level is the atom be excited. And when it gets excited, it expands due to heat transfer. So since it expands, the volume increases and the mass of the fluid retained. So it would be more dense compared to the region which is not directly exposed to the heat. So since the lower portion, which is the hotter one, become denser compared to the upper one, so the molecules will rise up. So once it rises up, the cooler region will now fall down or replace the molecules that's in the lower portion or the lower region. So this time, the cooler molecules or the cooler region will be now exposed to the heat. And the hotter region initially will be now exposed to the atmosphere, and the tendency it will get colder. And then once it gets cold, it will replace now the molecules that being exposed in the heat directly. So the cycle will continue and continue until, let's say, this liquid will boil. So the fluid flow itself is called convection current. We have the so-called forced convection, wherein the fluid circulation is being influenced or caused by a blower or pump. Another type of convection is natural convection or free convection, which is caused by the difference in density due to thermal expansion, as illustrated in this boiling water. So forced convection is being circulated by a blower or pump. The most important mechanism for heat transfer within the human body is a forced convection, wherein the blood serves as the pump. Our body constantly transfers heat in one direction or another to prevent the adverse effect of hypo or hyperthermia. Free convection in the atmosphere plays a dominant place in determining the daily weather, and convection in the ocean is an important global heat transfer mechanism. Convection heat transfer is a very complex process, and there is no simple equation to describe this phenomena. So let's have this comprehensive example. Hot water baseboard heating units are frequently used in homes, And the cooling devices are different because each is designed to maximize the production of convection currents. Where should the heating unit and the cooling coil be located? A. Heating unit near the floor of the room and cooling coil near the top of the refrigerator. Or B. Heating unit near the ceiling of the room and cooling near the bottom of the refrigerator. Correct answer is A. If the heating unit were placed near the ceiling of the room, warm air from the unit would remain there because warm air does not fall. Thus, there will be very little natural movement of air to distribute the heat throughout the room. If the cooling coil were located near the bottom of the refrigerator, the coil would remain there because cold air does not rise, it sinks. There will be very little convection to carry the heat from other parts of the refrigerator to the coil for removal. The air above the baseboard unit is heated, like the air above a fire. Buoyant force from the surrounding cooler air push the warm air upward. Cooler air near the ceiling is displaced downward and then warmed by the baseboard heating unit, causing the convection current, as illustrated in the figure. Within the refrigerator, air in contact with the top-mounted coil is cooled. Its volume decreases and its density increases. The surrounding warmer and less dense air cannot provide sufficient buoyant force to support the cooling air, which sink down. In the process, warmer air near the bottom of the refrigerator is displaced upward and is then cooled by the coil. So let's test your comprehension. Try to answer this one. When you first step out of the shower, you feel cold, but as soon as you are dry, you feel warmer, even though the room temperature does not change. Why?